Hi everyone, welcome to day 10 of my cloud computing series. So today we are going to learn this topic. First, what is classless addressing? Second, subnetting in classful addressing. Third, variable length subnetting. Fourth, subnetting in CIDR. And fifth, variable and VLSM in classless. IPv4 header format. Sixth and seventh is option and padding in IPv4. 8 IPv4 header format. Ninth IPv6 header. Ninth, what is routing. 10th, distance vector routing algorithm. 11th, link state routing in computer networks. So I'm going to my network nodes. So if you see classless addressing introduced in 1993, so there is a no, like a block. This is a block. All this is a block ID. It's a network ID and this is a host ID. If you see, and there is a mask. Mask is nothing but a network ID. Okay. So if you see, this is the XYZ/n. So it is a number of bits represent block or network. It's a we can say also block mask. Okay, so it's a network ID if 28. If you see, so rules, address should be continuous. Number of addresses a block must be in a power of 2. First address of every block must be evenly divisible with size of block. Okay, classful. Subnetting, what is subnetting? You're dividing your large network into sub network, like a sub network or small networks. That is called subnetting. If you say this is a class, this is your network and your class A, or you're dividing your this network into exam, place, extra, and um, ABCD, anything else. So this is you are dividing like this. So you can take this example like this, you can understand, like S126, S2 126, like that. Variable length subnets masking, VLSM. So it's like we are dividing by variables, like this will be 50%, this will be 20%, this will be 30%, divided by, like we are by length we are dividing or subnetting network, like that. So it's called VLSM. Okay, and if you see subnetting in classless interdomain, you can see interdomain there will be like this. You can example take this like this example, then you can understand. Okay, so I'm not going to explain in detail, so I'm just overviewing what I have learned. So variable length subnetting in CIDR classless, so it's like we are dividing like this only. You just understand this problem, then you will understand. uh, IPv4 header format, if you see connectionless datagram service, and if you see there is this is a format, a variable and a header length, and type of service, which type of service, total length, and identification byte, flag, fragmentation of site, time to leave, TTL, and protocol, header checksum, source IP address, and destination IP address 32 bits, option and padding. Okay, datagram header size is equal to 20 byte, payload is like this. So you can understand through this the differentiated series code point, DSP. Okay, explicit conjunction notification, fragmentation, this is the fragmentation, in identification byte 16, flag 3, what is flag 3, DF 00, and if in MF, so one will be for 0, and it's like that. Okay, option and padding in IPv4 header, record route IPv4 में नहीं due to security reasons. IPv4 6 नहीं है due to okay, in routing. And this is your routing, this R1, R2, R3, and this is your source, so D1, and the like source and destination, and R1, R2, like that. So this packet will be going like this, source routing strict source, like that. It's passing like this. So you are going to your message will be um, received at this destination, padding and all. IPv6 headers, this is the what is the version of that, is showing that is by IPv6, like that, priority, float, label, payload and length, and the next header, hope, limit, source address, destination address, based header. This all kind of you can understand. This is the extension routing number. All these are base header, extension, and all extension header and data. If you see routing is so important, and if you understand this routing, you will also learn how the internet works. So routing protocols is there is inter-domain and intra-domain and inter-domain. In intra-domain there is distance vector and link state, RIP or OSPF, and path vectoring in inter-domain, BGR. Okay, they all work in the unicast status manual. Okay, if you see like this diagram you will understand. Like intro domain, intro domain is nothing connect this device connecting to this device is it's called intra domain. And if you they are both the devices from different source, different network, then this called inter domain. It's intra domain, it's inter domain. If you see this diagram you will understand. Distance vector routing, like how the routing tables work, or how routing works, or how they have all that node like address and all they are storing like this. And if you understand through this only labor, only distance, you will understand this example. If you want to know, you will see the computer network playlist of gate measure. You will understand that distinct vector ladder DVR how works. So you will understand, okay, routing tables work like this, and also you will understand better. So how they change their path and all everything, it's like next and all you will understand better. Okay, if you count infinite problem, there is a problem also, and everything. Link state routing, if you see link state routing like a sequence, time to leave, how the time to leave like that, floating there, bandwidth there, every conjunction and everything is there. So I hope I have explained very well. So we have learned this all topics. So we will going to learn new topics tomorrow. Till that time, bye.